All right, ready to go?
Hi, good morning. Excuse me. Here we go. Hi, good morning. My name's Tom Nadeau, and I'm going to talk to you about SDN this morning. I want to jump in your seats there. Just to give you a little background on myself, I'm Chief Architect of Open Source at Brocade. I run our controller and OpenStack, OPNFE, and a variety of other projects internally. There we go. Excuse me. Wow, that's on. So what are the drivers for SDN? So over the last 20 years, we've had a sort of rapid increase in scale of storage, compute, and networking. And what's happened, is also a switch in traffic demand, and so what's happened is compute, data center, storage, these sorts of things have all evolved to sort of match that demand. Networks unfortunately haven't changed much. All we've done is made the pipes fatter, for example. But what we've not done is glued networking to all of those sort of innovations, and that's what SDN really is about, is doing that. So what's changing, right? Things that need to change. We've got sort of device by device changes in the network. We've got evolution of standards. We've got proprietary software today. Again, I mentioned network, storage, compute, and those things are all changing to sort of logically centralized network control rather than sort of device by device control. Open standards are changing and evolving to more or less open source as de facto standards today. Proprietary software is largely going to open source, so I can tell you probably 80% of my customers in various sectors are all telling me that their direction is to look at an open source solution first and then a proprietary solution second if they can't find one, or build one themselves even. Network, storage, compute is converged IT, so all of these things working together again. And then hardware is largely moving to virtualized software, virtualization. And so what's happening here is, again, disaggregation and open software. I mean, that's how, let's talk about virtualization and software. And so if you look at what vendors offer today, they have their management plane, their control plane, all, device by device control, operation. They're all sold in kind of silos. They don't necessarily work together. Very proprietary, vendor-specific software stacks running on those devices, a lot of proprietary hardware on those devices, limited innovation, right, effectively. I mean, you've all probably talked to the Ciscos and Junipers of the universe and tried to get new features put in, and the response is, I can get that to you in 2 or 3 years. That's very unacceptable these days. And so where we're moving is, again, network-wide operation to have more logically centralized control over these devices, and again, open control and management and orchestration software built around that. These include OpenStack, Open Daylight, etc. And then what that allows you to do is it opens up the space for innovation. What I'm seeing, for example, with my customers today is not only do they like these kinds of solutions, but what it does is it allows them to innovate on the solution, allows them to iterate, develop their own applications, hack the controller, and so on. And what it also does is it opens up the conversation between the vendor and the user to one that can happen at a much more detailed level if they wish, which is kind of cool. Sorry, I missed that animation there. There we go. The other thing that's happening too that I should mention here too is the Northbound API. It's kind of unifying the view towards the network elements, and what it's doing is this is where, in particular, we're joining that storage and compute innovation with network innovation. Right? Until we had this sort of unified view of network elements, virtual or real. Things were difficult, and so network programmability is a big aspect of this whole change. So what does a controller do? Right, so in that previous picture, we're talking about logically centralized control. What do SDN controllers do? This is a picture, a simplified picture of the Open Daylight controller, although you can think of it as most of the controllers that are in the industry have some aspects of this in here, although I'd argue that you need all of these. At the top level, you have again applications and services talking to standardized, and by standardized I mean sort of commonly accepted in the industry, not necessarily requiring formal standardization, APIs that can be programmed to. Those APIs, then you can build applications onto regardless of what's underneath on that network. And then, of course, the controller provides certain services like location services, topology, certain control plane functions that you may want to offload from devices as well. And you can see, in the picture here, I'm showing, sort of disguised version of Open Daylight, but you have many southbound protocols which allow you to talk to a variety of different southbound devices. And that is also a key in the whole SDN and programmability conversation, in that there's no such thing as a greenfield network, really. And so adapting this new technology to existing technology is, sort of step zero in the process. Step one in the process is then to start doing those other new, cool, innovative things. But you definitely have to support the existing network today. Oh, keep pushing the wrong button. And actually, and so of course, my take is that all of this stuff should be open source based. Not to say you can't value commercial distributions of those things, and those are very valuable. But there's about 100 reasons why having this open source based is the way to go. Oh, I apologize, they duplicated that slide. So why open source? So here's a whole variety of good reasons, and in fact there's a reference here to a Fed IT document that actually talks about this. But you avoid vendor lock-in, right? So the Brocade controller is based 100% on the open source code. What we do is we wrap it, make it easy to install, support it, make it functional. There are a lot of moving parts, for example, so we make it easy to use. We also make it easy to use as a development platform, which again, if you play in the upstream code, is difficult. But on the southbound side of that previous slide, we support many vendors' equipment. We obviously support Brocade, but we support Cisco, Juniper, Alcatel, Ciena, etc. So that's important. I mentioned earlier, it gives you a seat at the table as a customer and a user. It allows you, for example, to look at the source code, right? So for the obvious security, performance sort of analysis that you may want to do, that's easy. You don't have to sit in a private room and get special access to my code or all that stuff. I mean, it's there, right? Take a look at it. It also allows you to develop features on that platform if you want. It allows you to evolve the platform yourself. And what that does is all of that results in faster innovation. it encourages me to innovate faster because I'm not, sort of artificially slowed down by the fact that, I can delay deployments by 2 or 3 years while I work on things. But it also allows you to innovate, and not just innovate with me. You can innovate with partners on that same platform. Everybody can use the same platform. It's really cool. And then easier integration. Again, I mentioned third parties above the controller, so there's a common integration layer. Everybody can see it. It's open. It's available. And you can modify it. So it's, again, not a 2 or 3 year process to change a variable in an API if that's what you need. And also, again, easier integration on the southbound side in terms of third-party devices, right, or other vendors' devices other than mine. That's something you can let me worry about, and then I can worry about doing that, or I can work with those other vendors to integrate in this platform. But looking at the platform from above, it's one common unified thing. Open source projects of note that are going on today. My teams are involved in all of these projects. Open vSwitch obviously is working on a programmable Linux kernel based accelerated data plane virtualized switch. We have Open Daylight, obviously, which is what our controller product is based on. Open Daylight, again, provides an industry-wide unified open source controller platform, and OpenStack as a viable alternative to commercial platforms like VMware. There are lots of others as well. I mean, I should have mentioned OP-NFV, which is trying to unify NFV and orchestration. That's an important open source project. We just had our first release, Arno, last week, I think, or the week before that. And a variety of others in here as well. So one of the interesting sort of conversations that's happening right now in the industry is around, frankly, do you need traditional standards in this space, not just networking, but applications, for example. So organizations like the ITUT, the IETF, or some of the other sort of pseudo-standards organizations like the ONF and so on. Do you need those organizations if you have open source projects? And so here is sort of the pros and cons and what you do in those organizations. So open standards define interfaces really well in human readable documents, generally speaking. The downside is that it takes quite a while to do that. Open source projects define interfaces well, but it's in code. So it's in running code is the documentation format. And you can argue that defining those APIs is potentially a little less stable, simply because it's in code and it's in running code, which can evolve rapidly. We're having this problem right now between the IETF and Open Daylight, where I run or co-run the NetMod working group at the IETF, where we define Yang models, right, which are used for doing a lot of modeling and data modeling these days. And so the question always comes up about, a model that's done at the IETF in an RFC format, which is sort of, set in concrete for a while, versus one that's done outside and open source but has running code. And there's this continual push and pull between the two, where people want to evolve rapidly, but they also want to have a stable base. So, customers want to be able to point at an interface and say, in an RFI and say, do you implement that? So it's a little give and take there. Open standards do a very bad job of defining behavior. In my opinion, so there's a lot of ambiguity beyond, say, defining like a finite state machine in a document. Whereas obviously running code is defined behavior, right? You can run the code and test it and try it. So there's definitely an upside to that. And again, I mentioned, normal standards organizations move relatively slowly. They take years to operate, and as you all know, traditional sort of telco standards interaction with vendors is in the past has been a 5, 6, 7 year process to go from the beginning to the end. Whereas open source projects generally kick out code in 3, 4, 5 months, and you iterate quickly. The question is that iteration better? Does it give you, stuff that's stable enough? And the answer is that it depends on the project, I think. Open standards often leave interoperability testing to other organizations, to users, and so on. That has been a sort of an interesting, sort of artifact of open standards. Whereas, because, as I mentioned earlier, open standards don't entirely define an implementation. They, at best, define most of an implementation, right? They define most of a protocol spec, but everybody always has extensions. Then the question is testing the interoperability of those extensions. Whereas open source projects, there's one code base, right? Generally speaking, if you take one distro of project A and another distro of project A, they're the same code. So what's to interoperate with? There are obviously exceptions to that, but in general, interoperability testing is much easier, simply because you have the implementation. Open standards sometimes provide open source implementations or reference implementations, but again, those are reference implementations of like 80% of what you're trying, to standardize. Whereas again, open source projects are the implementation. So that's clearly an advantage. So we're at the federal forum here, so of course we need to talk about, is open source secure? My argument is that it's generally more secure than closed source code. Simply speaking, the first quote there from Linus says it all, right? Given enough eyeballs, all bugs are shallow, right? So the code is there, you can look at it. There are obviously exceptions, right? So if you don't have a lot of eyeballs looking at the code, like the recent SSL vulnerability we had about a year ago, I think. If not enough people are working on that code base, then yeah, you're not gonna have enough eyeballs. But for example, in Open Daylight, we've got somewhere north of 350 developers working on this. And so, a good example is the second bullet point here. We had a vulnerability that was brought to our attention, and a patch was pushed and was included in my implementation in less than 4 days. And it's there, it's in public, everybody knows about it, it's not hidden, it's not kept quiet. That's a big advantage, right? So then the fix spreads to everybody. Everybody gets that fix immediately. You don't have things like, a version of Windows 98 running around on your network with vulnerabilities that were not patched because it's not supported anymore. These are fixes that come out very quickly. Open source, obviously supports, SSL, SSH, HTTPS, with strong ciphers and so on. These are all been qualified, in federal environments and work well as long as they're configured correctly. Open Daylight and some of the these are all protocols Open Daylight supports, and then obviously OpenFlow over SSL or NetConf over SSH or SSL, has the same advantages. Also, starting with Lithium, Open Daylight is going to be cryptographically signed. So when you download code artifacts, they're all signed, so you know you're getting what you think you're getting, to add another level of security. So in general, I was saying open source is generally considered more secure than closed source projects. Yeah, they duplicated this. 3 times. So let's define what open means in open source. So there's a variety of products out there today called open something. I'll argue that those are not necessarily open source. These are what are called open-washed projects. Open source is cool today, so everybody wants to get a piece of the pie, right? What you should ask yourself about is it truly open source? Because if it truly is, it has the advantages I just discussed. If it isn't, then it's probably more like proprietary software of the past. So who can contribute, right? So if you look at Open Daylight, who can contribute? Anybody can contribute. There's a membership list, and that really is a means to fund and sort of loosely steer the organization. But control of the actual projects and the code happens on a day-to-day basis is by coders and the projects, the sub-projects. OpenStack operates the same way. These are examples of true open source projects. Who does contribute is another important thing. I mentioned, if you have an open source project and 2 guys are contributing to it, that may mean the project is dead, or may mean there's no interest in the project, or both, right? And who contributes, you should check and see, open source again today is no longer this sort of, hippie project where everybody wants to share source code and all that. They're very real commercial underpinnings to open source as a methodology. And you should ask yourself, is it a multi-vendor effort, or is it one vendor really running this effort? That's an important consideration. And that also lends itself to part A, or the first bullet I had there. How are decisions made? Again, is it a multi-vendor project, or is there some Uber committee that you have to pay to play? These are important questions to ask. And if there's such a committee, who can vote? Do you vote more if you pay more? Things like that. And then, what license does it use? This is also important, right? Is it an Apache license or BSD license or whatever? I mean, not all open source licenses are created equal, so you have to read the fine print. And then about products, that are derived from these things. What are the integration vectors, and how does it integrate? Including APIs, right? How does it integrate with other products? How does it integrate with your stuff, with your DevOps, with your NetOps guys? Is the product based on all open source components or some? Some people don't realize, for example, your iPhone runs like 70% of the code on the iPhone is open source, BSD code. It's just sort of hidden from you. And does it upstream to open source projects? So does it just take, or does it give and take? That's also an important thing, and that'll tell you a bit about the company and its philosophy and its commitment to that philosophy of open source. And then simply stated, ODL is as open as it gets. All of these things, all of the sort of positive things I mentioned about open source are part of what ODL, or are how Open Daylight operates. So what is ODL? Real quick, ODL has all of these 3 important aspects. Has a lot of code, has acceptance by a broad community, and is operated on by a broad community. And who is ODL? ODL is these companies, plus there are other people that are not even members that are contributing to the project. So I got these stats here at the bottom: 300 code commits per week over the last 12 months on average. So that's showing a lot of commitment. Who's building products based on ODL? Obviously Brocade and some of these other guys. It's important to understand the differences between those products and how they're offered based on the questions I asked. Again, our I would argue our distribution is the most open and the most sort of purely transparent. And we can talk about that after. I'm running out of time here, but if you guys want to chat about that after. And analysts, you've probably read in the press, there's a lot of momentum around this project and its open source underpinnings. We're running out of time. I had a bunch of use cases I was going to talk about. And some of this stuff, yeah, I think we'll jump to, this will be my final slide here. So yeah, SDN is here. I mean, people sort of coyly have been asking, what is SDN? I mean, I can tell you what SDN is today. SDN is open source driven, programmability, community involvement, multi-vendor support, and so on. And to kind of wrap it up, the BVC controller, which they're demoing in the demo area, is a great example of that. So go check it out and take a look at it. Thanks for your time. Thank you.